Good morning. Please make sure you have in front of you your packet with day 15 open, and it should have geometry. Okay, before we begin, I'd like to first go over and review the types of angles. And remember, we did these angles with our body movements a lot this year. So I think you'll remember them. You won't have a problem trying to remember these angles. So our first angle is an acute angle. So you know how we used to say a cute little angle? Because we call it a cute little angle because it's an angle with a measurement of less than 90 degrees. So this is what an acute angle looks like. And when we talk about it being less than 90 degrees, a 90-degree angle looks like that. So an acute angle is less than 90 degrees. Okay. The next angle we're going to review is a right angle. And a right angle is that angle that has that exactly 90 degrees. And remember, a right angle is the angle that we can draw a little box on the inside. So if we can draw a little box inside that angle, it is exactly 90 degrees. So a right angle is exactly 90 degrees. Our next angle is an obtuse angle. And it is an angle with a measure greater than 90 degrees. So you see how this side of the angle stands out. And if it were 90 degrees, it'd be straight up and down like that, like the one before. But because it stands further than 90 degrees, it is called an obtuse angle. And obtuse angles have a measure of more than 90 degrees. So it's greater than 90 degrees. That makes it obtuse. A straight angle looks just like a straight line. So it's a straight angle and it has a measure of 180 degrees. So you know we hold our arms out to the side to make a straight angle. So remember the exercises we did to help us to remember the angles. So let's go back and recap. We know that an acute angle is an angle that is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is greater than 90 degrees, but it is less than the 180, the straight angle that is pictured below. And a straight angle is exactly 180 degrees. So keeping that in mind, okay? All right, so let's move on. And let's move to our lesson. The first one is an I do, and it reads, Stefan had the trapezoid below on his homework. What type of angle is angle ZWX? And remember, W is in the middle, so that is at the vertex of our angle. So we're looking for angle ZWX. So this angle right here, ZWX. Now, if I look at it, even if I turned it upside down, it's not one of those angles where I can draw a perfect square in there. So therefore, it tells me it is not a right angle. Not at all. Not a right angle at all. So when I look at it, I know that it looks like it's more than 90 degrees. It's not less than 90 degrees. If it were, it would be an acute. But this angle is obviously more than 90 degrees. So when an angle is more than 90 degrees, we call it obtuse. So obtuse angles are more than 90 degrees. So then this would be my answer choice because I know, because I know that an acute angle is less than 90 degrees, and that's not what I have pictured here. I have an obtuse angle, which is more. I proved that it wasn't a right angle because I can't draw that perfect square. It's not a perfect square. And a straight angle, I know it's nothing but a straight line, and it's 180 degrees, and that's not what I have here. I definitely have an angle. It's not a straight angle. So it is an obtuse because it's more than 90 degrees, okay? All right, let's go to our next problem. Here's the answer, just in case you missed it again. All right, our next problem is a we do. And it reads, which pair of letters have the same number of lines of symmetry? And remember, you had lines of symmetry yesterday. And lines of symmetry divide something in half, and they're identical on both parts. Okay, so this side is identical to this side. Let me change my view here. Okay. And here I'm looking for the same, I'm looking for the same number of lines of symmetry. Okay. So go ahead and make sure you've cubed that because I need to make sure I'm looking for the same number of lines of symmetry. And remember, symmetry means that both sides are identical. Okay, so symmetry means that both sides are identical. So let's look at our first two letters. We have E and we have F. Okay. So if I drew a line of symmetry through E, through here, that means this side and this side are identical. But if I did that same line through F, they're not identical. So that tells me right there that E and F are not my answer choices because already this one has a line of symmetry and this one does not. And remember, I'm looking for the one that has the same number. So let's go ahead and get rid of E and F. E and F won't work. So A would not be my answer, okay? So now let's go to H and I. So write H and I on your paper. All right, so you have a capital letter H and you have a capital letter I, and these are box letters. All right, so if I first take the letter H, if I drew a line through H, that means this side would be symmetrical with this side. So that means this part of H looks like this part of H. Okay. Let's see, if I did the same thing to I, then that means this part of I looks like this part of I. Okay, so far H and I have at least one line of symmetry. Okay. Let's draw a line a different way in H and I and see. So now let's write H and I again. Okay. And these are box letters. It's kind of hard to do box letters on the computer. Okay. So we have one line of symmetry going across. So let's do one straight up and down. So if I did one through I, one through the middle of I, one through the middle of H, then let's check to see. Does this part of H look like this part of H? Yes. Does this part of I look like this part of I? Yes. So far, H and I both have two lines of symmetry. Okay, so we'll stop right there. And then I'll give you a chance to write down N and O. And let's compare those. All right, so let's do an O. And we know O has an infinite number of lines of symmetry. No matter where I would draw a line on O, it would be symmetrical. So O has infinite numbers. That means it has more than any of the other letters. But when I draw a line of symmetry through N, do these sides look alike? No. This side looks alike? No. So we can go ahead and count that out because you know this one has a whole lot. This one doesn't even have one to start with. So we can get rid of C as an answer choice. Okay. Now you write down W and X and start making the lines of symmetry for W and X. Okay. So we draw a line down W and we take a look at both sides of W. Does this side look like this side? Yes, it does. So we could say, yeah, W has one line of symmetry. Let's do the same thing for X. We draw a line through X. And then we ask ourselves, does this side look like this side? Yes, okay. So W and X has one line of symmetry. Let's put it there. All right. Let's draw the lines a different way. Let's see what we come up with. Oops. We need to erase that. Okay. Let's write W and X again. Let's draw a line across. I draw a line across here and one here. All right, let's look at W. Does this part of W on this side of the line look like this part of W on this side of the line? Absolutely not. Okay. This side of X looks like this side, but yes, but they both have to have the same number. So let's go back. So D would not be our answer choice. So our answer choice would be B. And now stop a moment and let me get that. Okay, let's go to our next one. Our next problem is a redo. Excuse me. It says Ronnie has the trapezoid below on his homework. How many pairs of parallel sides does the shape have? I'll pause and let you cue that problem. Okay. So within the word parallel, so if I wrote that word parallel, P A R A L L E L. Little trick to help you remember what parallel lines are. Look at the L's in parallel, okay? There are two lines that run in the same direction but never meet. That's the definition of parallel. So you're looking for two lines that are going the same way, but no matter where they're going, how long they go on into infinity, they never meet. So remember we said a good example would be North Tryon and Graham Street. They run parallel, but they never meet. So we talked about some of the things in real life that would be examples of parallel lines, and that I recall that being one that we talked about. So let's look at our shape. Our shape has four sides, and our job is to figure out how many of the lines that are opposite each other. Got to be opposite in order to be parallel. How many pairs of parallel lines? Okay. So when I look at this side compared to this side, if I were to continue this line on, and then the opposite side, if I were to continue, those lines would eventually do what? You're right, they would eventually meet. So that side would not be parallel to the other side. So those are not parallel lines for sure. So now let's look at the other lines that are in this trapezoid. Let's look at the lines going this way. You have lines going this way and lines going this way. So if I extend those lines and they keep going, those two lines never meet. Well, I know a pair consists of two, so I have two lines. Two lines make up one pair. So how many pairs of parallel sides does the shape have? It has one pair. It's like you have a pair of socks, you have a pair of eyes, a pair of hands. So pairs come in two. So these two lines are parallel. So you have one pair. Okay? Your next problem is a you-do. And it reads, Karen has the clock below on her homework. What is the measure of the angle made by the hands of the clock? So trace up your angle in the clock. And then look at it. Remember what I told you earlier. Something special you could do, then it would be considered a right angle. If it's less than 90 degrees, it's an acute angle. If it's a straight, it's 180 degrees. So you figure out what would the hands be. Okay. On this particular problem, the next problem, which is a you do, it says which polygon must have two sets of parallel sides. So here you don't have the pictures on your book. I put the pictures on here for you. So you will not have an excuse, and you're looking for two sets of parallel sides. Two sets of parallel sides. So basically you're looking for two pairs, okay? Then your last problem is a you do. It says which triangle represents symmetry correctly. And remember with symmetry, one side has to be identical to the other side. So here's my line of symmetry. You look at this part of the triangle. Does it look exactly like this part of the triangle? If it does, then that's a line of symmetry. If it does not, it is not a correct line of symmetry. So you have to figure out which one of these has the correct lines of symmetry, okay? So once you finish, please make sure you put your answers in Kahoots. Please make sure you put your name and only do your Kahoots. Somebody is still doing other people's Kahoots. So please don't do that. It's not fair. So make sure you do your Kahoots, and I'll see you on Tuesday. One thing to mention, Monday, will be recorded because Monday I have to go to the school to pack up my room. So all fourth grade will have recorded lessons on Monday as well. Make sure, and that's in your new packet, but it's something you reviewed before. Okay. All right. Have a great weekend. Please take care of your moms this weekend because it is Mother's Day. And I'll see you on Wednesday. Bye-bye.